discuss about the computer registers about the computer registers in computer organization subject. Friends, we already know that the computer organization or computer structure is best defined by the three things. One is the set of registers. The second one is the instruction set or set of instructions. The third one is the timing and control signals. So, under that one, we are discussing about the registers. We know that generally the instructions are stored in memory in a consecutive memory locations, that is first instruction suppose a plus b in first location, the second instruction c minus d in second location, the third instruction e into f in third location, like that. These instructions for processing fetched from the memory to the processor. So hence we has the doubt where these instructions are stored within the process. So we know that the registers are located in process. Okay, where is the registers? The registers are in process. These instructions are fetched from the primary memory and stored within the registers before processing and during the processing. For example, the first instruction a plus b stored in the R1 register, the second instruction c minus d stored in R2 register, and the third instruction is stored in third instruction E star F. So like that. So first we can remember that registers are in processor. They contain data and information. These registers are divided into two types. One is the general purpose registers, general purpose registers. The second one is the special purpose registers, special purpose registers. The general purpose registers, I am simply call it as a GPR. The general purpose registers are represented by the capital letters R1, R2, and so on. These are storing the data and instructions. The special purpose registers, generally I am going to be call them as SPR, special purpose registers, has the name like that AR, PC, and DR, like that. These are the names for the registers. These represent specific function or simply an action, right? The special purpose registers has the names and these are represented specific work or function or action. So now we are discussing about the what are the special purpose registers are required for a basic computer. So this is today our topic. Okay friends, how many and what are the specific special purpose registers are required for the designing of the basic computer. So there are at least 8 special purpose registers are required for designing as well as working of the basic computer. I list them here. The first one is the data register, simply represented as the DR. The second one is the address register, AR. The third one is the accumulator or processing register, no, represented as AC. The fourth one is the instruction register, IR. The fifth one is the program counter, PC. The sixth one is the temporary register, TR. The seventh one is the INPR, input register. The eighth one is the output register, OUTR. Friends, here we are going to be represent each and every register perform a specific action, and the size or length of the registers are entirely different from each other based on their functionality. Suppose the basic size of the register is the 16 bits. We are already discussed in our previous video. Here the data register DR consisting of 16 bits. The address register AR is consisting of 12 bits length, right? Because we know that the basic computer consisting of 4096 words of memory, and each word consisting of 16 bits length. We are going to write that 4096 by 16 memory capacity, right? Accumulator, this is very important. This is known as the processing register. This is again 16 bits. IR, instruction register, this is also the 16 bits. The program counter, this is also consisting the address of the memory location, so this is 12 bits. And temporary register, to handle or to store intermediate results, this is also the 12 bits. And INPR, input register, this is 8 bits. And output register, OUTR, this is also 8 bits. Here I given one more clarity, what is the need of the temporary register and each and every register. Suppose I am going to be add 5 plus 3 plus 2. Actually, I am adding first these two, 5 plus 3, 8. Generally, we remember this value in memory, but the computer used this temporary register to store this value temporarily. After that, to this 8, we are going to be add 2, the total value 10. Now the total value 10 is sent to the output register, right? OUTR. Suppose anything we are going to be press, either letters A, B, C, and numbers, suppose 1, 2, 3, from keyboard, those are sent to the input register, actually, right? Through input register, those are go to the data register in the processor, DR. The address register is used to represent the memory addresses. Okay, friends. Now I am going to be draw the structure of the registers, how those are in the basic computer, including the memory. So please observe this one. We are going to be consider. We are going to be consider. This is the memory. This is the memory of the computer, which consisting of 4096 words, and each word length is the 16 bits. This is the memory. So to fetch the data or instructions from the memory, we need the address of the memory location. Hence, I am going to be draw here the address register, AR, whose capacity is 12 bits. So the address of the memory location is available in address register, right? After getting the address of the memory location, either we fetch the data or instructions, we keep it in the data register. Suppose we fetch the data, we keep it in the data register. This capacity is 16 bits. Or we fetch the instructions, we keep it in the instruction register 0 to 15. Here also I am write 0 to 11, total 12 bits. Right? This is the instruction register. After we are going to be keeping these data and instruction in instruction register, we are use the processor, we process the data according to the instructions in the processing register. This is important. This is known as the accumulator. This is also the 16 bits length. So getting the data and the instructions, we are going to be processed within the processing register accumulator, right? Suppose is there any temporary results, we are going to be using the temporary register. This is also the 16 bits. This is the TR. So the results are after processing the results, the output is sent to the output register. This is the only 8 bits length OUTR. So suppose we are going to be getting the data from the keyboard and something else. We are using the one more register that is known as the input register INPR. INPR. This is also the 7 bits. So the one instruction is executed. How we are going to get the next instruction? The address of the next instruction is available within the one of the special register that is known as the program counter. This is also the 12 bits. So initially we remember that the address of the memory location, these address of the memory location, suppose this address of the memory location is suppose 112, the next location is 113. Let us consider initially the address of the memory location, that is 112 in the program counter. From program counter to it will come to the 112, here come to the address register. When the address from the program counter to address register is transferred, the program counter, that is address of the next memory location, is automatically updated. Now this is 113. So we can remember that or understand that the program counter consisting the address of the next instruction to be executed. By using this address, either we fetch the data or instructions either to the data register or instruction register, right? After that one, these instructions are sent to the processing register accumulator. Is there any temporary results that are stored in the temporary register? Otherwise, those are sent to the output register. Suppose we send the information from the keyboard, those are stored in the input register. Okay, friends, I hope you can understand this one. Thank you.